Welcome to Neon Math. Today let's learn and practice 6 ASVAB type math knowledge problems, specifically algebra, with variables. Before I begin, I'd like to talk a little bit about the distributive property. Most of you are familiar with the distributive property. Let me show an example. Distributive property is when we find ourselves with a constant or a variable bumped up against parentheses. And it's the idea that this is being multiplied, well, times everything inside the parenthesis. Here I have a 5 being multiplied. That means the 5 has to be multiplied times everything inside. We don't get to choose. We have to distribute it. Some teachers will say like a paper route, delivering the paper. Some people are like, what? They deliver newspapers to houses? 5 times x is 5x. This says 5x, just like that said 5x. And 5 times 7 is positive 35. So you just write it down. And that's it. It's done. You leave it alone. Do not try to combine these two. They're not in the same family. This is the constant, just number by itself family. And this is x family. They don't get to be added together. They just get to sit next to each other, happy as can be. This parenthesis that we had down here and this one right here, these are called binomials, where you have often a variable and a constant, just a number, separated by addition or subtraction. And that's basically it. Here we had just a single number multiplied times a binomial. Here we have two binomials being multiplied together. What do you do? How do you multiply these together? I often say, well, it's like Christmas. X and negative 2 are going to go to a party over at X and positive 7's house. And so X is going to bring one gift for each of the neighbors. And negative 2 is also going to bring a gift for each of the neighbors. So X has to be multiplied times everything in the other parenthesis. And this negative 2 has to be multiplied times everything in the other parenthesis. Notice they're not multiplied times each other. All right? So how do we do that? Well, x times x, that's a little tricky. When we multiply x times x, we are doing a few things. First of all, we are multiplying the invisible coefficients in front times each other. We don't talk about it because 1 times 1 is 1. But we are also have to remember that when x is just sitting there, it has an invisible exponent of 1. And when you multiply variables, if you multiply x times x, or any of the same variable multiplied together, you have to add the exponents. So x times x becomes 1 plus 1 is 2, x squared. Just memorize that x times x is x squared, or y times y is y squared. Just memorize that. Put that away. You don't have to think about it much. But if you do have to think about it, this is how it works. And 1 plus 1 made 2. Next, x got multiplied times 7. And x times 7, or 7 times x, is just 7x. Pretty simple. Next is this negative 2 times x. And negative 2 times x is just negative 2 times x. Do not leave behind the signs. We need those. That's not a 2, just a 2 being multiplied. That is a negative 2. And then negative 2 times positive 7 is negative 14, because a negative times a positive is a negative, or a positive times a negative is also a negative. We're almost done. We have one more thing we have to do. We've got to scan through here and see if there's any like terms. I have an x squared here. There's no other x squared, so that's done. I have this number, just a normal number, not connected to any x's. And it's the only one there, so it comes down. These two, though, this positive 7x and negative 2x, they can combine. As simple as 7 minus 2. And 7 minus 2 is 5x. So if I had 7x's and I took away 2x's, I would now have 5x's. And that's it. I can't combine any of these together. Moving on. Now let's take this problem we just did and superset a binomial times a trinomial. Same concept though. This guy wants to give gifts, he wants to multiply times every single term over here. All right? And then this negative 7 is going to be multiplied times every single term in here. As you'll notice, I haven't shown any multiple choice yet because I want to teach you the fundamentals without looking at kind of the strategies of the multiple choice. But if I was doing this problem, which is very time consuming, as I'm going through the problem, I would be thinking and looking down at the multiple choice to see if any of my answers, if what I'm coming up with, if there's only one answer that represents that, and then I would go choose it and I'd move on. But I do have to be careful because when I work out all these 5x squareds times these three, I eventually might combine them with one or two of these, and that could change my final answer, okay? Because I'll have to combine like terms at the end of this problem, just like I did right here. All right, let's jump in. 5 times negative 2 is negative 10. Notice I didn't add or do anything weird. That's only when I'm messing around with the exponents. Then I have to follow the weird exponent rules, okay? So 5 times negative 2 is still negative 10, just like it's always been. Now x2 times x3 becomes x to the 2 plus 3 is 5. When we multiply those, we add the exponents. Next, 5x squared times 5x. Don't forget that there's a little 1 there. And then that makes it easier to remember. Okay, I'm going to multiply the front. 5 times 5 is 25. And x2 times x1 becomes x to the 2 plus 1 is 3. 2 plus 1. Okay, next. 5x squared times negative 3. 5 times negative 3 is negative 15. Positive times a negative is a negative. 5 times 3 is 15. X squared. Don't forget that. So 5 times negative 3 is negative 15, x squared. And if you're thinking, wait, you're combining things that aren't alike. Yeah, because I was multiplying them. When I multiply, I can do some extra cool things. But when it comes to the end of this problem where you have to add and subtract, I'm not allowed to add and subtract things that aren't in the same family, that aren't like terms. Okay, let's move on. Sorry, my color coding is not matching up with my arrow swoops. Now, over here, a negative times a negative is a positive. 7 times 2 is 14. X cubed. Negative 7 times negative 2x cubed. Don't forget to bring the x cubed. Negative 7 times positive 5 is negative 35x. And finally, negative 7 times negative 3. A negative times a negative is a positive. 7 times 3 is 21. Okay, now I have to scope through here and see if I can find any like terms. This is the only x5, so I'm going to bring it down. Now, at the very beginning of the problem, if I look down at the answers and realize there was not going to be any more x5s in this problem, like this negative 7 couldn't multiply and make any x5s, and there was only one answer that had an x5 in it, I'm going to grab that answer and move on. You want to try to get these problems done in 1 minute if you can. All right, next, I have no x4, but I do have a couple of x3s right here. And so I'm going to combine those together. 25 plus 14, I'm adding, because all these are just separated by adding and subtracting now. Clumps, terms of things where things are being multiplied, but I can move these whole terms around just by adding or subtracting. 25 plus 14 is 39. X3. Why was I able to put those together? Because they were both same variable, same exponent. Okay, so I was able to add those together. On my scratch paper, I might cross those out just to know that I already brought those down. X3s are done. Let's see if I have any X2s. This is the only X2 right here. I can bring it over. 15X2. I'm running out of room. I have a minus 35x, no other single x's, x to the first powers, and 21. And there we go. That's it. I'm done. Whew. That was a crazy expansion. A lot of work. And what are you going to do? All right, number 3, clean screen. Okay, recognize these are in what's called standard form, where I have some x term, some y term, an equal sign, and a constant. When you see that, start to think, oh, systems of equations. I have, in both of these, I have an x and a y, an x and a y. Second thing to look for, do I have two things that are the exact opposite of each other? In this case, it's a positive 1y and a negative 1y. Yes. And when that's the case, we can do something really pretty cool. And that's, we can just stack these right on top of each other. 3x minus y equals 6, and 2x plus y equals 4. If you don't think you're going to remember this, and this is not your thing, they want us to find out what y is. So you go down to the multiple choice answers and you try each one of those into y, but it has to work in both. Has to work in both equations. Once you plug those in, you might be able to figure out what x is, and it has to match up. Plugging in is a science, but I'm going to teach you the way that you can't fail at this problem if you remember how to do this. Okay, so we're going to add this up. I stacked everything. The x's are lined up, the y's are lined up, the equal signs are lined up, and the numbers, the constants are lined up too. 3 plus 2 is 5x. These are exact opposites, a positive 1 and a negative 1, and they're both y, they're gone. And now I'm down to one variable. 6 plus 4 is 10. Why is that important? Because now I can solve this. And if you don't remember how to solve simple 1 or 2 step equations, go watch my other videos. Opposite of multiplied is divide. I said multiplied. Those cancel. 5 divided by 5 is 1, and x equals 10 divided by 5 is 2. I know what x is. Go look up and make sure we look at what the question's asking. They want to know what y is, not what x is. So I do have to take this x equals 2 and go plug it in. I'm going to plug it in here where it's a positive y, so I don't have to deal with this negative right here. And so I'm going to plug it in for x. We plug it in for x. It says x equals, but I'm using this equation because it has a positive y. So I'm going to plug it in right there. So it says 2 times x. I'm going to write 2 times, instead of x, I'm going to put in my answer, plus y, my nice positive y, ready to go. 2 times 2 is 4. I need that y by itself, so I'm going to get this to the other side, and the opposite of positive 4 is subtract 4. And if I do it to one side, I do it to the other, and oh yeah, y equals 0. I finally found the answer. Okay, what values of x are solutions? If you were in my algebra class, I would say, hey guys, this is one of those fun puzzle problems where we can factor out. We can turn these into parentheses like this. And it's a puzzle. We need 2 numbers, okay? Remember the first problem that we did where we multiplied binomials? We're doing that backwards. And so what the puzzle is, you need to find 2 numbers that multiply to make 36, multiply to make 36, but those same 2 numbers need to add up to 12. So can you think of 2 numbers that multiply to make 36? 12 times 3, 9 times 4, no. 6 times 6. Is 6 plus 6 12? Yes. You drop those in. We were able to factor out, and something times something equals 0. So this needs to equal, one of these needs to equal to 0. What plus 6 makes 0? Well, not 6 plus 6, not 0 plus 6, but negative 6. Both of these are the same, and so x equals negative 6. And that's my answer. Now, if you're not going to be able to remember that, and that's not how you want to attack this problem, here's the other way to do it. Let's look at this problem. I have a bunch of positives adding up and make a 0. So if I were to plug in 6, it'd be some really big number, positive, plus another number, positive, plus another big number that's going to be way bigger than 0. Positive numbers aren't going to work. Let me try 0 in here. Let me change the color so we don't get lost. Let me try 0 in here. 0 squared would be 0. 12 times 0 would be 0. 0 plus 36, still not equal to 0. So can't have this one either. So negative 6 would be the only one that would work. Because we're going to have something that will cancel out this positive 36 because we've got to come back down to 0. So we're going to have some negative in here to get rid of this big positive. So just a little strategy. Next problem. Okay, notice there's a 4 in front of here, and there's something in front of this. In our last problem, there was just a 1 in front, so it was very easy to factor out. This one, not so much. So I'm going to have to use a little bit of strategy, maybe some guess and check. 0 is so easy to plug in, so let's just go try 0 out. 0 squared times 4 would be 0. This would be 0, and 0 plus 16 would be 0. That's not going to work. Okay, so 0 doesn't work. All right, let me try. That didn't work. Let me try 2. It's right there. I'm plugging it in. 2 squared means 2 times 2, and 2 times 2 is 4. So this would be 4 times 4, which is 16, minus 2 times 16 is 32, or 2 times negative 16 is negative 32, plus 16 equals 0. These 16s could combine together to make 32, and 32 minus 32 would be 0. So that works. Thinking about negative 2 in there, negative 2 would give me the same thing. It would be 16, because negative 2 times negative 2 is 4. So it would give me the 16. But negative 2 here would be a negative times a negative would give me positive 32. And then I'm back to that thing where I have a positive plus a positive plus a positive. It gives me a really big number that's much bigger than 0. So in this case, a negative wouldn't work. I could try 3, but I already tried 2 and it works. Moving on. Okay, that's the problem we just did. Yay, we're done with that one. Okay, let's simplify this one. Oh, there's a lot going on here. We saw that when we multiply variables with exponents, we add the exponents together. The other side of that coin is when we divide exponents, we subtract. All right, so let's get in here and do some subtraction. First of all, 24 divided by 12. I'm doing the inside of these parentheses first before I mess with this cube out here. 24 divided by 12 is 2. So I'm going to have a 2 in here. I'm looking forward. I know that I'm going to have to, this is the only constant in here. 24 divided by 12 is 2. It's the only constant, and I'm going to have to cube it. And 2 cubed means, this tells you how many to multiply together. So this means take 3 2s and multiply them together. 2 times 2 times 2 is 8. I know that at the end of this problem, I'm going to have an 8. I'm going to run down and look at the multiple choice. And if there's only one that has an 8 in the front, that's my answer. But knowing them, they'll probably have 2 or even 3 that has an 8 in the front. So carry on. Next, I want to attack these. P15 divided by P7 is P to the 15 minus 7. And 15 minus 7 is 8. Q3 divided by Q2 is Q to the 3 minus 2 is 1. I'm going to leave that 1 there. It'll be helpful. R to the 5th divided by R to the 2 is R to the 5 minus 2 is 3. All right. We have now learned that when we multiply, we add the exponents. When we divide, we subtract the exponents. What happens when we try to raise an exponent to an exponent? That's when it gets a little bit crazy, and we basically just multiply, okay? So we are going to cube every single thing inside here, okay? So let me change my color, and so 2 cubed. Now I'm not going to cube my exponents, the exponent rule with exponentizing That's my own little verb. Exponentizing an exponent is you multiply, okay? So each of these are going to get multiplied by 3 because of this 3 out here. 2 cubed means 2 times 2 times 2. I already told you it was 8. P to the 8 times 3 is 24. Q to the 1 times 3 is 3. And R to the 3 times 3 is 9. And that is fully simplified. As I was going along, I could have looked down to multiple choice to see if I could stop the problem early. You gotta be real careful with that, okay? Now it's your turn to self-assess. Try these 6 problems. Pause the video, try these 6 problems, and see how you do. And when you come back, we'll work them all out together. Welcome back. Problem number 1, multiplying binomials. These are the ones where we have to multiply everything. Well, almost everything. This x gets multiplied times everything in those parentheses. Then this positive 6 also gets multiplied times everything in those parentheses. We just got to be really careful as we go along, follow certain rules, and we'll be in great shape. Don't forget that this is x1 and x1. When you just see an x, there is an invisible 1 exponent. Just memorize x times x is x squared, and you'll be in really good shape for a lot of problems. These do happen to have 1 coefficients, and 1 times 1 is 1, of course. But anyways, x times x is x to the 1 plus 1. Got to add those exponents, because that's a weird exponent rule. 1 plus 1 is 2, so x squared. Next, x times negative 7. Negative 7x. Now for positive 6. 6 times x is positive 6x. And 6 times negative 7 is negative 42. You look down at the multiple choice answers on your ASVAB and you're like, I don't see the answer there. Good. You're not done. You have to combine like terms. And these two happen to be in the same family. This is the x squared family. Nobody can combine with it. Not when we're adding and subtracting. We multiplied to our heart's content up here, but when it comes time to combining, we can only combine things that fit in the same family. Constant family, just normal numbers, nope, by itself. But negative 7x plus 6x, 7 minus 6 is 1. 7 is bigger than 6, so it's negative 1x. There we go. I gave you a little easier expand problem than we had earlier. We're going to multiply everything times each other. All right. I'm going to put little 1 and a little 1 to remind me, hey, don't forget. So here I have 8 times 4, and that's 32, just like it's been since you first learned that 8 times 4 is 32. But then with exponent rules, y1 times y2 becomes y3. We add those exponents. Okay, that term's done. Next, 8y times 3y. 8 times 3 is 24. Go play those multiplication games. You got to learn your multiplication tables. y1 times y1 is y squared. And finally, 8 times negative 6 is negative 48. Positive times a negative is a negative. Don't forget the y. I can't combine anything together because this is in the 3 family, the 2 family, and the 1 family. All right, next. I told you start recognizing those standard form equations when we're doing systems of equations. There's going to be usually an x, a y, equal sign, and a constant when it's in this form. Also, we're looking for, are there anything that are exact opposites? I have positive 1x and negative 1x. Because we need, well, we need a variable to cancel. So we can figure out what the other variable is. This is asking us to solve for y, which is a little easier than the sample problem I did earlier. Because y is the first thing that we're going to actually calculate. Let's stack these on top of each other. I got negative x plus 2y equals 12. And x minus 6y. We are solving by elimination. Solving a system of equations by elimination. You may have learned that in algebra. Negative and positive x, they just cancel. 6 and 2, opposite signs. So 6 minus 2 is 4. Keep the sign negative because 6 is bigger than 2. And 12 plus 4 is 16. Now to finish this, I just have to divide. The opposite of multiplying is dividing. I'm going to divide -4 to both sides. And y equals 16 divided by -4. Positive divided by negative is a negative. Just like a negative divided by a positive would be a negative. And y equals -4. They asked us to find y. We're done. If they had asked us to find x, we would have taken this y and we'd gone and plugged it in. I would have plugged it in here because this x was a positive x ready to go. I wouldn't want to have to mess with the negative sign of that one. We would plug the -4 in here, we'd calculate, we'd move around, and we'd find out what x is. But in this problem, we didn't have to do that. All right, notice this has a coefficient of 1. When there's a coefficient of 1, we can actually turn these back into parentheses like the opposite of what we did for problem number 1. It's called factoring. If that doesn't work for you, I'll show you another strategy. But this puzzle is pretty simple. Okay, there's x because x times x made this x squared. This is a puzzle. We need to find two numbers that both multiply to 25 and add up to 10. That's the puzzle. So if we can figure out two numbers that multiply to 25, like 5 times 5, that add up to 10, like 5 times 5, we'll know what our factors are. And these happen to be identical, meaning we're only going to have one answer. So it's going to be one of these two. What this is saying here is that something times something equals 0. So either this equals 0 or this equals 0. And what would make this equal 0? What plus 5 would just cancel out 5 and make a 0? And that would be a -5. And that's our answer. Now, like I said, if this is not your thing and you don't want to learn this, well, what you need to do is you have to go plugging in stuff and thinking about it. I would plug in 0 first. I would plug in 0 and say, okay, this 0 squared is 0. 10 times that would be 0. 0 plus 25 does not equal 0. So 0 can't be one of my roots. And then I would try the other two problems. If I was going to try a positive number, this is getting messy, I know. If I was going to try a positive number, 5 squared would be a really big positive. 10 times 5 would be a really big positive. Plus 25, you know it's going to be way bigger than 0. So a positive is not going to work in that case. So it has to be this negative. All right. With this coefficient here, I'm not going to try to factor. It's just too difficult. So I'm going to have to just come in old school and just power through. I'm going to try 0 first. 0 squared times 9, that's 0. That's going to become 0. Plus 36, that does not equal 0. Okay. All right. Now, let me see here. If I tried plugging in -2, -2 squared would be 4 times 9. That would be positive. And a -2 times a -36 would give me a positive number. So a positive plus 36, it's going to be a big number, which is not equal to 0. So I know my answer has to be one of these two. And I'm just going to go try plugging them in. Let me try 2. So 2 squared is 4, and 9 times 4 is 36. So 36 minus 36 times 2 is 72, plus 36. 36 and 36 is 72, and 72 minus 72 does equal 0, so that works. If I'm talking too fast, there's a little gear at the bottom right. You can always slow me down or speed me up or pause it or rewind. But make sure you understand everything I say. All right, let's simplify. I'm going to come in here first and divide this right here, the 9 and 18. Notice small, big. It's going to be a fraction, basically. I could go over here and reduce it, divide 9 top and bottom and get 1/2, and reduce it to 1/2. The way I think about it, if I can, is 18 divided by 9 is 2. And the 18 was on the bottom, so the 2 gets to stay there. 18 divided by 9 is 2. But that's the same as 1/2. I just don't need to leave the 1 up there. Next, all the big exponents are up on top, so all the letters are going to stay up on top. T, 14 minus 11. Remember, when you are dividing, you subtract the exponent. So 14 minus 11 is 3. 4 minus 2 is 2. 6 minus 5 is 1. And I'm going to leave the 1 here. And then we still have to bring everything to the 4th power. And this is how we do it. 2 to the 4th power. This is just a normal number, so it actually gets used as an exponent. Now, how do you raise an exponent to an exponent? You multiply. So when we multiplied, we added our exponents together. When we divided, we subtracted our exponents. But when we raise an exponent to an exponent, we just multiply. Leaving me, in the end, with t to the 4 times 3 is 12. U to the 4 times 2 is 8. V to the 1 times 4 is 4. Now 2 to the 4th power, the 4 tells you how many 2's to multiply together, so I'm going to multiply 4 2's together. 2 times 2 is 4, times 2 is 8, times 2 is 16. My goodness. Now as I was doing this problem, I would have been looking ahead at the multiple choice answers to see if I was getting close to the answer. This one's a hard one because you don't really know what you have until you get to the end of it. Hope this helps you. If you need more help on solving equations, etc., go check out my videos. Good luck and have yourself a wonderful day.